Count the number of lines in each shape in the sequence of complete graph. Which number sequence do you get? Can you explain why? So first I'll go start with your complete graph. So this is your K2. This you don't have to do it in your exam. This is for me to explain it to you guys. So K2 has one line. Then we have K3 that has 1, 2, 3 lines. Then we have K4 that we have 1, 2, 3, 4, 5, 6. Then we have K7. Sorry, no, what am I doing? K5. So we have traditional 1, 2, 3, 4, 5. And we have 6 and 7, 8 and 9, 10. There are 10 of it. K6 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I miss anything? Yeah, 15. So on and so forth. So what are we looking at? This is your rectangle number, right? So the sequence which we are looking at is actual answer would be. So the question is you have to look at the complete graphs in your textbook, count it, and that's what you're supposed to be done. But I'm doing it for your understanding. So actually your answer starts over here. So we have 1 and then 3 and then 6. Then we have 10 and 15 and so on and so forth. Now the question is why? That is the difficult part. So I put it this way. This is a note again. This is not part of your answer. Now to draw a line, how many points do we need? Yeah, how many points do we need? 2 at least, right? If I give you guys a single dot, so am I talking about this direction length or this length or a line with this length or is this length or is this direction? We will not be able to fix. But if I give you the second dot, there's only one option for me to draw a straight line and this is it, right? On the surface, this is it, a single straight line. So we need 2. So if I have one more dot, then I'll end up with connecting this and this, so on and so forth. So basically, for every dot, I'll have to connect with other dots which are one lesser than the number of sides the figure has. What I'm trying to tell is, here I have, how do I put it across? Here I have one dot. I have to connect it to other dots. Here I have, in this figure, I have 4 dots. So every dot has to connect to 3 other dots, right? Here I have 5 dots in total, but every dot, say point A, has to be connected to B, C, D, and E. So in this figure, wherein we have A, B, C, D, E, F. So from A we have 1, 2, 3, 4, 5. From F we have A, B, C, D, E. So in K6, every dot is connected to 5 other dots. So for every dot, there are 5 different dots being connected. Agree? And so 5 different lines being connected. Right? That's the next fact. Second fact is every dot is connected to total number of dots minus 1. Every dot is connected to total number of dots minus 1. Number of dots. So basically, what do we end up with? We'll end up with total number of dots minus 1 into total dots. So many lines will be there. Do you guys agree? Are they different or are they same? That is something else, but at least we got to know that, okay, A is connected to 5 dots with 5 lines, B is connected to 5 dots with 5 lines, is also connected to 5 dots with 5 lines, so on and so forth. So 1, 2, 3, 4, 5, 6. So 6 into 5, 30 lines are there. But you can see the answer is 15. Why is that we are getting 30? Here A is connected to 4, 4, 4, 4, 4. So 4 5 is 20, but the answer is 10. Why is it 10? But when we count it, we are getting 20. Because we are recounting. Let me explain that. See, when I tell that A is connected to D, E, B, C, should I count from C again to A? No, because it's already counted. So whenever we do this, we are counting a line 2 times. Every line we are counting 2 times. So number of dots, right? Each dot is connected to total number of dots minus 1 number of dots. So basically we are looking at total number of lines is equal to total number of dots into total number of dots minus 1 divided by 2. I could have done a better job with this actually. I do have space. This entire thing is getting divided by 2. Why divided by 2? Because every line is counted 2 times. As every line is counted 2 times. So if I'm counting something 2 times, what should I do so that it will reduce to the original number? Is it not? Divide by 2. If I have, say, 10 people, if I'm counting 10 people 2 times, so it will add up to 20. So if I want to get back the original number, I'll divide by 2. As simple as that. Every line is connected. Not connected, sorry, counted. Oh yeah, I did write counted. 2 times. Right, with this methodology, whatever we counted with the above methodology, we end up with counting 2 times. So to undo that, we are dividing with 2. So I've given a proper explanation that you guys can use it in your exams. This pattern occurs because in a complete graph, every dot is connected to every other dot. To figure out, that is to find out. This means find out the number of lines. Take the number of dots you have, multiply the number by 1 less than the number of dots. For example, if you have 4 dots, you will get to multiply 4 by 4 minus 1, that is 3. So 4 times 3 is equal to 12. This method will give us the triangular number. This counts each line 2 times. Because line from dot A to dot B is same as line from dot B to dot A. So to get the actual number of unique lines, you simply divide the result by 2. In our example, 12 divided by 2 will give us 6 unique lines, different lines, right? That's why we end up with 6 over here. Again, this is only for explanation for you guys to understand over here. If it's not needed per se as per the question, if they ask you, then you have to draw. There's no other option. If not, this is only for explanation. this is your actual answer. So all of this is again for your explanation.